In this video, we're going to talk about simplifying and manipulating trigonometric expressions. We're going to look at basic identities and Pythagorean identities. Okay, here are the basic identities that we have. An identity is an equation that is true for all possible replacements of the variables. So on this side right here, we have the reciprocal identities. And then over here are some more common notations of how to rewrite tangent and cotangent in terms of sine and cosine. And then these ones over here are basic identities that relate back to the unit circle and the correlation between the angle measure and the sine and the cosines. Okay, so let's look at our first example. Multiply and simplify the following expression. So here we have our multiplication sign. So the first thing that we want to do is FOIL this. So I'm going to FOIL this into here and get cosine y sine y times cosecant y. Then I'm going to FOIL this into here and get plus cosine y sine y times tangent of y. Now I'm going to rewrite this in terms of its reciprocal and rewrite this in terms of its identity. So I'm going to end up with cosine y sine y. And we know that cosecant is 1 over sine y plus cosine y sine y, and tangent y is sine y over cosine y. Alright, so on this side my sines are going to cancel out and I'm going to be left with just cosine y. On this side over here my cosines are going to be canceled and I'm going to be left with sine squared y. Alright, let's take a look at our next example. Same thing here, simplify the expression. So the first thing we need to do is factor in this sine of x, sine x, cotan x minus sine x, cosecant x. I'm going to rewrite cotan sine x equal to cosine x over sine x minus sine x. Do the same thing with cosecant x again, rewrite it in terms of its reciprocal function, sine x. Alright, so on this side my sines are going to cancel and I'm going to be left with cosine x. And my sines are going to cancel on this side and I'm going to be left with a 1. Alright, so if we take a look at the Pythagorean identities, I'm going to talk briefly about this one. This is our main Pythagorean identity, and if we look at the unit circle, we know that each point is represented by cosine, comma sine. We know that our radius for a unit circle is 1. So if you recall, the equation for a circle is x squared plus y squared equal to the radius squared. So here, instead of having x squared, we're actually going to have cosine squared. And instead of having y, our y term is actually sine squared. And as I said before, we know our radius is 1, so 1 squared is still just 1. And that's where this very important first Pythagorean identity comes from. After obtaining the first identity, we can divide the first identity by sine squared x and get this one. Then we can again take this first identity and divide it by cosine squared x and obtain this one. So that gives us our 3 Pythagorean identities. Alright, let's look at our next example here. So here we have basically two fractions with different denominators and we're adding them together. So in order to be able to add these together, I need to have the same thing on my denominator. So on this side, I need to multiply it 1 minus sine x, multiply top and bottom by 1 minus sine x. And very similar over here, I need to multiply this side by 1 plus sine x on top and bottom. All right, now I'm going to distribute this cosine x plus sine x cosine x. So now my denominator, I have 1 plus sine x times 1 minus sine x. Now I now have the same thing over here, 1 plus sine x times 1 minus sine x. And distributing my cosine over here, I get cosine x minus cosine x times sine x. All right, so now since I have my common denominator, I can combine what's on top and write it as one single fraction. So I have cosine x plus sine x cosine x plus cosine x minus cosine x sine x. And I'm going to go ahead and FOIL out the bottom just so we see what we have. 1 minus sine x plus sine x. Oop, that last term is going to be a minus sine squared x. Okay, if we look and see what we have on the top, we'll see that we have a plus sine x cosine x, and we also have a minus cosine x sine x. These two terms are going to cancel out. And on top, I'm left with 2 cosine x. Simplifying the bottom down here, I have 1. Yet again, I have a minus sine x and a plus sine x, so these two terms are going to cancel. So on the bottom, I'm left with 1 minus sine x squared. So if you recall that first Pythagorean identity, we have sine x squared plus cosine x squared equal to 1. And here I have a 1 minus sine squared x. So if I subtract sine x squared from both sides of my equation, I'm left with cosine squared x equal to 1 minus sine squared x. So now since I have the same exact thing here and here, I can replace this with what this equals, which is cosine squared x. So now I have 2 cosine x all over cosine squared x. This cosine is going to cancel with one of these cosines, and I'm going to be left with 2 over cosine x. All right, so if we look at this next example here, we have sine to the 4th minus cosine to the 4th. So basically what I have here is the difference of squares. So if you remember difference of squares, it tells me I take the first one minus the second one, and I'm going to multiply it by the first one plus the second one. So here, if you don't believe me, we can double check our work really fast. So if I FOIL this back out, I'm going to get sine to the 4th x plus sine squared x cosine squared x, and then I have a minus cosine squared x sine squared x, so those two terms are going to cancel, and I'm going to be left with a minus cosine to the fourth x. So in checking my work, I did obtain the original sine to the fourth x minus cosine to the fourth x. I'm going to erase this so I can see what I have. So looking at what I have now, this right here is my Pythagorean identity, my very first one, which equals 1. But over here, this has a subtraction sign, and we have two things being squared. So again, over here, we have the difference of squares. So we take the first one, subtract it from the second one. First one plus the second one. And here, this is about as far as we can go. We can't really simplify this any further than what we have right here. But again, if you wanted to check your work, if we multiply the first, we're going to get our sine squared x outside, sine times cosine x inside. We're going to have a minus cosine times the sine, so those two terms are going to cancel. And last, a minus cosine squared x. So in checking our work, we are going to get the same thing, and we in fact did factor that correctly. And that is really all there is to simplifying and manipulating trigonometric equations.